let's have a look at factors that affect the resonant frequency of open and closed pipes in general. And the same as there was for strings, there's three main factors that we should think through. The first one's the length of the pipe. If we think about that open pipe, the wave that's set up in the pipe has to always fit in the pipe. The length of the pipe has to always be n number of half wavelengths, an integer number of half wavelengths. And with the closed pipe, the length of the pipe must always be an odd number of quarter wavelengths. And those even ones, no can do. They don't work, but it's an odd number of quarter wavelengths. But in either case, we can see that the length of the pipe and the wavelength are directly proportional. And so that means that as we increase the length of the pipe, we're increasing the wavelength of the wave that can resonate inside the pipe. Longer wave with the same wave speed, that means that we've got a decreased frequency because the V is constant. Other factors, things like temperature of the gas, is actually really significant. Like a few degrees air temperature makes a significant measurable difference to the speed of the sound travelling through the air. And so as that gas temperature increases, the wave speed also increases. And that means if we're keeping the length of the pipe the same, that means that the wavelength is going to be the same. As the speed of sound increases, the speed of the wave and the gas increases, that means that the frequency must increase. And that's why you hear orchestras and that, they tune up, right? They really are warming up the instruments, because if you just play them cold, they play a little bit too low a frequency. They sound a bit flat. So it's really important to warm up if you want to sound good. The density of the gas is the other thing. We've all seen people sucking in a balloon full of helium and then talking like Donald Duck. Well, there's other gases that you can suck in, and then it makes your voice go the other way, makes it go deeper. And what's happening there is that we're introducing different gases that have different densities, and it turns out that when the gas is really dense, we get a really low wave speed, a really low speed of sound, and if the gas is a really light one, like helium, we get a really high speed of sound, because we're keeping the wavelength the same, like inside our voice box or whatever we're playing around with. That means that as the wave speed increases, the frequency must increase, and the same if the wave speed decreases, the frequency must decrease. So those are the factors that we need to know about that affect the resonant frequency of a pipe.